All right, so Brandon Lamoncha here with Humtown Additive. Get to sit down with Aaron Howard from Voxeljet. Aaron, thanks so much for sitting down. We're at day 3 of CastExpo. We recently installed a VX1000 at the facility, printing direct phenolic, and it's been going really good. Customer response is great. So just wanted to have Aaron on and just kind of talk about things that are happening over at Voxeljet, and just basically open format, but just what's new, and how are you seeing the show?
Well, I guess to go backwards then, the show's been really good for us too. I think we had a lot of foot traffic today and Saturday. Yesterday was a bit more lull, like we were just kind of saying, but to be expected. A lot better turnout than I thought would be the case, especially for a weekend show. So that was also good, kind of refreshing, and even comparison to like AMOG, I think the foot traffic's been even better. And granted, it's industry specific versus AMOG's not really, but still it's nice. It's very refreshing to have a pocket full of business cards for once instead of lint and tire kickers and head scratchers, and we can do that ish, so.
Well, even compared to 2019, I mean, it was still, just in the last couple of years, I mean, for us, it's been a lot more of discovery and, hey, can you teach me about this, to now it's like, these are all my customers, and a lot of these customers are production customers. So, I mean, just in the last couple of years, even through COVID, I mean, the difference from just teaching people about the technology, or like you said, tire kickers, to people that are actual users, whether they buy a system, use your print service center, or use like us or Hoosier. I mean, it's dramatically different.
100%. 100%. Yeah, it's been. I used to say a big part of my job is marketplace education. And now it's not. Now it's train the trainer. Right. They have SMEs in place. And they've gotten their hands dirty, and they've made enough mistakes to be dangerous. Right. So now they really want to make some really big mistakes that cost them lots of metal on the floor. Right. So that's been definitely the case. I totally agree. Which is, it's refreshing, because that's, for me as an engineer first, that's our goal, right? Like, sales are nice and they'll come in, but it's better to know that you've done your job and that's made the sale, rather than just to sell a product that speaks for itself, right?
Yeah,
so,
for sure. Yeah, it's been amazing, seeing that transition from, from people wanting to do even prototyping or new product introduction to full-on production. Seeing the engineers now, from what you've taught them, I've taught them, from AFS's standpoint of teaching, that they're actually grabbing a hold of this and seeing, the consolidation, or taking the opportunities.
Truly DFAM, right? It's truly designed for additive manufacturing. It's no longer just, well, now this is a new tool in the toolbox. We can manufacture
we can make it faster, which
faster,
you can. It's great.
Or cheaper, or I can take some quality issues away, right? Core setting and glue and these sorts of things. That's always nice and it's refreshing, but it's fulfilling when you see a product go from on paper to fulfillment with always printing in mind. Right, the whole time. And you can see it's evident throughout the process, right? And there's things that you can get that are key takeaways to look at that and say, that yes, not only is it still synonymous with what you're used to, and yes, it's another tool in the toolbox, but now you actually have process improvements because you've thought about it, in this new novel type of way.
Right.
Absolutely.
Yeah, I mean, and I've seen as of late, we all have talked, almost everybody I've sat and talked with at the show, the human capital, having the people to actually do the work is probably a portion of the uptick, because of a lot of our work now is just the core. It used to be, we're going to print a mold and we're going to print a core with it. Now it's like, no, we're actually printing cores in production. And some of those were direct STL scans from a core box, because they didn't have a CAD file, but they needed the cores imminently. They had line down situations, etc. And a lot of it is really, human capital. People need people, and
absolutely.
I don't know. I've seen some of the stuff, but do you have any automation or anything, in the works or in the States already, or is it being worked on in Germany? Like, take us, do you have any complementary technology that you're doing at Voxeljet to address the automation?
So yes, at large, yes, and I think there's no secret there. About 3 years, going on 3 years, right? GIFA 3 years ago, we introduced some of our partners with Loramendi and some of the industrial core production that we're doing there. So I can't really get into specifics because it's customer-based stuff, but yes, there is automation that's being built around primarily cells, which has been largely developed for the IOB systems, the silicates. However, there is now some of that being geared towards phenolic. So now we're which maybe this is a little new, but so we're starting to do a hybrid approach now too, even in phenolics.
Okay.
That's very similar to the IOB system.
Okay.
And it's to address many of what you've just stated actually, is that at first this was, everyone understands FA and we want to make mold packages, and that's nice to get me into production or PPAP or APQP or bridge gap or RP, but not necessarily production.
Right.
But how can I do that? Oh, I can hybridize, right?
Yes,
which is great.
for sure.
Sure. Print the cores, ram the sand for the tools, buy patterns, this is all great. This is all still good. But when you start to design for AM, now you have to actually think about that mindset and getting that captive asset and making it work so it can be an HMI and be safe to be around people and automated to get down line to actually be there and be a production device. So yes, we recognize that, and I think it's a good segue because it's where I think we all have to go next, right?
Yeah.
Now that we've shown that it can be used as more than just RP, we have to show exactly how you can incorporate that without too much more.
I mean, to be fair, most of the machines, to me as a core maker, right? I came from a CNC shop and grew up in a core shop. A lot of the machines tend to look more like a piece of lab equipment than a truly industrialized, commercial, production piece of equipment. And to be fair, that's what they started out as, and I think we are starting to see a little bit more of an industrialization, a little bit more of and I mean, I know like for ourselves, we're actually going to have a gantry, we're going to have a robot basically that's on a gantry that's going to service both boxes on one of our X1 pieces of equipment. And that, is basically to bridge this gap. We have the job box is done, it comes out, but if there's not people to start extracting, and that's where a lot of companies are having shortages getting people, we have to start looking at automating that. And I don't think that's necessarily on the machine provider, you know what I mean? Because but I think we work together, and as long as like you said, it's a cell, it's a specific application, and I think as long as both parties know that it needs to be done and we're working together, I think that's what the future is going to look like.
Oh, for sure. It's definitely a value add. We're
definitely having a hard time getting people into the industry, but the cleaner, the more automated, we're going to get more of the engineering type that are going to want to program and set up those cells, as opposed to people that want to just go dig into the sand and pull out cores day after day after day after day.
Right. Yep.
So a little bit on the phenolic side. I mean, so we've been very happy. Our customers have been very happy with the process. Just what are you seeing from your end? I mean, so from my end, we're using it for the smaller, maybe aerospace, type core. So any other applications, as a new user or people that don't have a system, what are you seeing, on the phenolic system that Voxeljet is pretty much in full production? What would you say the other benefits are for somebody like ourselves that's a new user in that area?
So you kind of touched on it a little bit early on, which I'm thinking of a couple programs where it is the most appropriate, and for one particular user it became the solution because of this in the end, is that core consolidation.
Yeah.
Right? So we had a particular customer that actually I think you're familiar with too. There was a 14-piece die to put together a pattern set that then got glued together in 14 different pieces, and they had somewhere around a 30% success rate with.
Okay.
Now they're near 100.
Yeah.
We have one out of a couple hundred scrap castings versus.
So was it? I mean, so we can do that in. You can do that on your system in Furion or in phenolic. But it was the phenolic the driver due to core breakage, gas evolution, all of the above. So it's a stronger process.
At first, it became about gas evolution because the glue that was required to put together all these cores was causing some gas issues. But once we printed the consolidated core, so we started this as there were essentially three main body pieces, and then 11 little cores that we consolidated into one and amalgamated. And the customer still wanted to see about gluing that in place because they felt like it was easier to access.
Okay.
We said, okay, sure, we'll try that. Why not? And they started getting pinholing. This is a high pressure aluminum casting. They started getting pinholing, and especially a lot of the blind faces that were trapped against there's a shear wall with a bunch of small cores that look like this.
Right.
So in here, there's a lot of burn-in and a lot of porosity and some issues.
Yeah.
So we said, well, in Furion, you can't integrate this core to the base and clean it out because the toluene makes it still too sticky to get the unbound particulate out of there, and so it's blind.
It's the cleaning,
so it became
and
a
the ability issue to clean that part. Okay, I understand.
We were able to not only guarantee the core was in true position, but would have less gas evolution, because even if even if, let's say, we do print it in Furion, we can clean it out, it's still alcohol, and it's volatile. Right? So they're aluminum, they're pouring at 1305, 1310, somewhere in there, and the Furion ignites at 1194, right? So even still, they were still getting gas. With the phenolic system, not only do we get that higher area strength because it's polymer, right? It doesn't volatile erupt as soon as the aluminum goes in, and so they get the opportunity to hold that good dimensional accuracy without burning in and introducing porosity and oxidization of the metal, right? So it became, at first, a chasing gas issue, and later became, oh, well, not only were we chasing gas that went away, we're now in true position, so we've lost all of our dimensional accuracy issues. How much further can we go? And now it's a two-piece core set. Right? So it's a completely integrated core. It sits in the drag. They have an adapter even, so on the cope piece, we'll call it a cope, it's more like a cheek, but the cope piece slides on, and it has an inlet valve on it that matches up to their pour line. So they have a filter block that even can insert directly into that and slap it right on the core line, and it's done. Right? So this is everything you want it to be is a process, and you can get 135 per build. Right? So they found that how were they able to integrate that into production was to print half builds, harvest the next day, put the second box in while they're harvesting, and they can run 3 days a week, no problem. No problem. And they're able to produce everything they need and then some. Yeah,
because I think even, as a service provider that has both, binder systems, it's good to know. And I think people, that are kind of just coming into the industry are looking for those opportunities, when and where to use which binder. And I don't know if there's a real good tool out there to really say if, then, type of matrix. So
well, if it's big and cheap, it's going to be FA,
for
right?
sure.
If it's scary, you start with phenolic, right? And then work your way backwards.
Sounds
generally.
Good. Yeah, that's a good rule of thumb.
You probably start to see is, if you have an awkward part that looks like that, right? In Furion, this is expensive because you're throwing away this material anyway. And if this is, a simple parametric shape, Furion's probably fine. Right? Unless it's a metallurgical issue. Whereas if this is a complex part, it's going to be phenolic first. Right? And then if there's some reason to put in Furion, which there usually isn't, then sure, you can go back. But generally, if it's scary, phenolic is the right answer. If it's not scary, Furion is just fine. Yeah,
and the phenolic's nice because you can recycle 100% and just put it right back into the process. Whereas the FA, you have that, the acid buildup, from the activator. So.
For sure. And sometimes you can get away with you using it, like we do with our ceramics sometimes, right? So the cost of materials justifies the end, but you can only do it if you run it the next day because your acid demand value starts to go down and you're too far depleted to recoat it. So just as soon as you're throwing a trash can. So. If that's something that is kind of a side benefit too, so I appreciate that, is that foundries that are particularly sensitive to waste or waste stream,
for sure,
phenolic is a very suitable answer. So maybe it doesn't matter which binder system you're using, but it matters what waste stream you're generating. Right? And so with phenolic, I mean, we throw away about a week, right? 1 week worth.
It fell on the floor, and we swept it up, and that's what we're getting rid of.
And it's also nicer on the machines too, right? So the head life hurts, because it is a heated process. But the machine, it's cleaner than our plastic process next door. No joke. And it's nice that it's still an industrial asset. So as clean and nice and pretty of a product as it makes, you can still slap it on a dirty foundry floor and it's just fine, right? So that's kind of the nice added benefit there too, right?
Well, it's been great. Any other insights or anything else from Voxeljet's point of view that you wanted to mention to the people that are going to be watching? Or I mean, I really appreciate you sitting down. And
thanks.
It's been good to catch up. It seems like we're always learning.
Ditto, for sure. Only as good as the information we share with each other and that we can accumulate through the customer base too, right?
And it's been good to get back in person. We do these things and it's like, you do them over the internet, you do them over the Zoom, but getting in person, I mean, we had some really great conversations with our clients. I'm sure you have as well, and it's good to be back in person.
Yeah. Oh, for sure.
Exciting times to come.
Indeed.
Aaron,
Indeed.
thank you so much.
Appreciate
you sitting down.
Yeah. Likewise.